Our first step is a black box test, focusing on the user experience. We execute a positive test case by entering valid credentials. The login is successful, and the user is redirected to their profile, confirming core functionality works. Next, we execute a negative test case using equivalence partitioning. We attempt to log in with an intentionally invalid password. The system correctly displays an error message. Password is wrong, please try again. A second negative case attempts to log in with an invalid, non-existent email address. The system successfully blocks this attempt. We apply various event type filters, such as trail cleanup, and confirm that the event list updates and clears correctly. This ensures the data presentation logic is sound. A critical functional test for event creation, intentionally setting an invalid time constraint. The start time of 9 a.m. is set after the optional end time of 7 a.m. The event is created, but a critical logic bug is exposed. The duration is incorrectly calculated as minus 60 minutes. This confirms a failure in input validation, as the system should have prevented a start time from being after the end time. The process begins on the account settings page. The user initiates the password change by clicking the Change Password button, which triggers a notification confirming that a password reset email has been sent. The user then navigates to their Gmail inbox, where they locate and open the email titled Reset Your Password for Geode. Clicking the embedded link in the email directs them to a new page where they can set their new password. After successfully entering the new credentials, the user clicks Save, which redirects them to the sign-in screen. Finally, the user enters their email and the newly created password to log in, confirming the reset was successful as they land on their My Hiking profile page.
We now shift our focus to input validation, a critical layer of defense against injection-based attacks. Here we enter a typical malicious SQL payload into the password field to test how the system handles unsafe inputs. The application immediately rejects the attempt and returns a secure error response, confirming that its backend defenses are active and effectively neutralizing SQL injection risks. This also lays the groundwork for our next XSS validation test, ensuring all input data is properly sanitized before processing. Next, we test for cross-site scripting by inserting an XSS script into the name field on the account setting page. When we try to save, the system displays an error, saving failed. Please fix the input errors. This confirms that the input sanitization is successfully implemented, blocking the malicious script execution. Our final pen test stimulates a brute force attack on the password reset. We repeatedly trigger the reset flow. In a real scenario, this would test for rate limiting or account lockout mechanisms to ensure the system defends against credential stuffing. We record what the server sends back to check whether it slows down requests, temporarily blocks repeated attempts, or raises an alert when it sees too many tries. We conclude with the white box testing, inspecting the backend's event logic using the eventservice.test.ts file, a mocked Firebase dataset, and super test calls verify that the events API filters data accurately without accessing the real database. Finally, we run npm tests to confirm that all unit tests pass, validating internal logic, consistency, and backend reliability. We inspect the backend's event logic using the eventservice.test.ts file. A mocked Firebase dataset and supertest calls verify that the events API filters data accurately without accessing the real database. Finally, we run npm tests to confirm that all unit tests pass, validating internal logic, consistency, and backend reliability.
This demonstration showcases our end-to-end testing, also known as E2E testing, for the Geode web application using Cypress. So first, we define the full navigation flow. E2E testing falls under the category of system-level black box testing, where we test the application flow from the user's point of view without looking into the internal source code. The purpose is to ensure that every integrated component, front-end, back-end, and APIs work together as one complete system. In this test, Cypress automatically opens a real browser, visits the login page, enters demo credentials, and verifies successful navigation across the main modules, which are profile, trails, events, and reels. This simulates an actual user journey from start to finish, validating that all key functionalities behave correctly under real usage conditions. By automating this process, we confirm that the system is stable, integrated properly, and delivers a smooth user experience.
Overall, the testing process strengthened our confidence in Geode's performance and security. Each test revealed valuable insights that guided improvements across both front-end and back-end components. With all key checks complete, the system is now ready for deployment, stable, resilient, and secure.